on. The next question is from application of determinants and what we call Kramer's rule. Though we don't really need to have the entire rule in mind, just we can make do with the basics. So we are given a system of linear equations. So basically we have three equations in three variables. So the first step of the rule was to evaluate the determinant of the coefficients. Here it is 1, 2, 1, 1, 0 alpha, 2 minus 3 beta. We subtract the second row from the first row. We'll get 0 here and 1 minus alpha here. We subtract 2 times the second row from the third row. We get 0 and beta minus 2 alpha here. Now we'll expand this determinant along this column. We'll get the determinant values minus 1 into 2 beta minus 4 alpha plus 3 minus 3 alpha. So this is 2 beta plus 3 minus 7 alpha. Now if this is 0, so basically this is 0, 0 when beta is 7 alpha minus 3 by 2. This is 0 when beta is 7 alpha minus 3 by 2. So P is if beta is 7 alpha minus 3 by 2 and gamma is 28. So when beta is 7 alpha minus 3 by 2, we have x plus 2y plus z equals to 7, x plus alpha z equals to 11, 2x minus 3y plus z upon 2 into 7 alpha minus 3. So we'll try to eliminate, we'll try to match the coefficient of z in these two equations. Which will give us, for that we'll multiply the first equation by 3 by 2 and the second by 7 by 2 and then add these two equations, or rather subtract this equation, the second equation, from the first equation, so that we'll get matching coefficients for z. So we have the second equation will become 7x by 2 plus 7 alpha z by 2 equals to 77 by 2. The first equation becomes 3x by 2 plus 3y plus 3z by 2. So this equation minus this equation becomes 2x minus 3y plus z upon 2 into 7 alpha minus 3 equals to 77 minus 21 by 2, which is 28. So if beta is 7 alpha minus 3 by 2, now notice that in this equation and this equation, the left hand side are the same. So for the system of equation to have any solution, gamma needs to be 28. So for option P, if beta is 7 alpha minus 3 by 2 and gamma is 28, then the third equation becomes a linear combination of first and second equation, which gives us infinitely many solutions. And gamma is consistent, gamma is 28. So we'll have infinitely many solutions. So P is mapped to 1. No, sorry, 3. Infinitely many solutions. Q is mapped to beta is 7 alpha minus 3 by 2. Though that makes the third equation a linear combination of first two. and then we'll have that gamma needs to be 28. If gamma is not 28, there will be no solution, because basically this will give us that this expression is gamma, this will give us this expression is 28, and gamma is not 28, then we'll have a contradiction, so basically no solution. Then R, if beta is not 7 alpha minus 3, alpha is 1, gamma is not 28, then we'll have a unique solution. So we are given that alpha is 1, yeah, so alpha is 1. Substituting alpha as 1 in the second equation, we get x plus 2y plus z is 7 and x plus z is 11, which gives us y equals to minus 2. And putting z equals to 0, checking fourth and fifth option for this. So fifth option is cannot be correct, because y equals to 4 won't satisfy the system of equations when alpha is 1. So for R and S, both 5 cannot be the answer. But let's check the fourth option. X equals to 11, y equals to minus 2, and z equals to 0. That will make x equals to 11. Using this and this equations, we can conclude this, and notice that these solutions are consistent with these two equations. And putting these values in the third equation, we have 2 times 11 minus 3 times minus 2 plus beta times 0 to gamma. So this comes out to be 28. So if gamma is 28, then the system of equations will have fourth option as the answer. And if gamma is not 28, we'll have a unique solution, but it would be dependent on beta and gamma. So we cannot say if the unique solution would be from 4 or 5. So answer is 3, 2, 1, 4 mapped to PQRNs respectively.